Alright, we're going to look at some examples of adding and subtracting rational expressions. Just like with other fractions, before you can add or subtract, you got to have like terms. And in this particular case, we do have like terms, and those like terms, or like denominators, are 3x plus 1. Therefore, since we have common denominators, all we need to do is add up our numerators and keep that same denominator. So I'm going to start by adding my two numerators. I'm going to add the 7x plus the 8x. If I add 7x plus 8x, I get a 15x. Now notice there's nothing to add 5 with, so I'm going to bring that 5 over. And all I'm going to do is keep that same denominator, 3x plus 1. So at this point, I've added my numerators and got 15x plus 5. Kept my denominator, 3x plus 1. But just like with other fractions, we got to see if we can reduce this. So I'm going to factor both the numerator and denominator if possible. 15x plus 5 can be factored. The GCF there is 5. 5 times 3x would give me 15x. And 5 times 1 would give me 5. Now I go down to the denominator. Can't factor it, so it's going to stay 3x plus 1. As you can see at this point, I can cancel out some common factors, and those common factors are 3x plus 1 and 3x plus 1. Therefore, I'm left with 5. Therefore, when I add these two rational expressions, the answer is 5. Alright, second example. Notice this time we're subtracting the two rational expressions. Also notice that the denominators are the same. Therefore, I'm going to go straight to subtracting my two numerators. So I'm going to start with a 3x squared, and I'm going to subtract 2x squared. So 3x squared minus the 2x squared would leave me with 1x squared. Now I'm going to subtract the x's. So I've got a negative 2x minus 3x, and a negative 2x minus 3x would be a negative 5x. And now I'm going to subtract the constants, the 1 minus the negative 5. And 1 minus a negative 5 would be a positive 6. So this is what I get when I add my two numerators. The denominator x is going to stay. But again, just like with other fractions, we got to see if we can reduce this. So I'm going to factor as much as I can. X squared minus 5x plus 6 is a trinomial with a leading coefficient of 1. Therefore, the factors are going to be in the form x times x will give me the x squared. I'm looking for factors of 6 that are going to add up to a negative 5. In other words, what can I multiply together to get 6, but they're also going to add up to a negative 5. In this case, that's going to be a negative 3 and a negative 2. Negative 3 times a negative 2 gives me a positive 6, and a negative 3 plus a negative 2 add up to a negative 5. Therefore, these are my factors of x squared minus 5x plus 6. The denominator x cannot be factored. Now if you look at what I have here, you'll notice there are no common factors that I can cancel out. Therefore, this fraction or rational expression cannot be reduced. Now I can leave it in its factored form. That would be acceptable. Or I could also leave it in this form over here. Either one of those would be acceptable. Alright, example number 3. We're going to add these two rational expressions together. Notice again how we have common denominators, x to the third plus 125. Therefore, we're going to leave that denominator alone. What I am going to need to do is add up my two numerators. So I'm going to add up the like terms. 2x squared plus 1x squared would give me a 3x squared. Now I'm going to add up the x's. I've got 15x plus a negative 1x, which would be a 14x. And now I'm going to add up my constants. A negative 6 plus 1. Negative 6 plus 1 would be a negative 5. So this is what I get when I add the two numerators together. But we need to see if we can reduce or simplify this. So what we're going to do is we're going to factor both the numerator and the denominator. So what I'm going to do is take that 3x squared plus 14x minus 5 and factor it. So I'm going to do my scratch work over here. I've got 3x squared plus 14x minus 5. I'm going to use the bottoms up method. Notice I have a leading coefficient of 3, therefore this is why I'm using my bottoms up. So the first thing I'm going to do is rewrite this as x squared plus 14x minus 15. Negative 15, because that's what I get when I multiply 3 times the negative 5. Now I can factor this. We know that x times x will give me x squared. I'm looking for factors of negative 15 that are also going to add up to a 14. In this case, those numbers are positive 15 and a negative 1. 15 times a negative 1 is negative 15, and 15 plus a negative 1 gives me a positive 14. However, I'm not done yet. Gotta divide each of these numbers by 3. That's that leading coefficient. So if I take the 15 and divide it by 3, that now gives me a 5. Now notice if I try and divide 1 by 3, that would give me a decimal, and we don't want that. So we're going to bring that bottom number up in front of the x, which is why they call this the bottoms up method, minus 1. So these are my factors of my numerator. Alright, so I'm going to go ahead and bring that over here. I got x plus 5 and 3x minus 1. So these are my factors for my numerator. Now I'm going to factor the denominator, x to the third plus 125. This is the sum of cubes. So the first thing I'm going to do is take the cube root of x to the third, which is x, plus the cube root of 125 would be a 5. Therefore, this is one of my factors, x plus 5. Now I need a trinomial. So to get this trinomial, we're going to take this first term x and square it. So if I take the x and square it, I get a x squared. Remember, this next sign is going to have to be opposite of what I have in my binomial. So I'm going to have a minus sign there. To get the next term, all I'm doing is taking these two in the binomial and multiplying them together. So the x times the 5, x times 5 would give me a 5x. And the last term is always positive. And to get that positive number, all we're doing is taking the second term in the binomial, which in our case is 5, and we're squaring it. So if I square the 5, that would give me a 25. So these are my two factors of x to the third plus 125. Again, this is called the sum of cubes. So let me bring those factors over. I've got x plus 5, and I've got x squared minus 5x plus 25. So at this point I have everything factored. Now I'm going to go over here and cancel out some common factors. I can cancel out the x plus 5 and the x plus 5. At that point, that's all I can cancel out. So I'm left with 3x minus 1 as my numerator, and x squared minus 5x plus 25 for my denominator. Therefore, this is my final answer.